Right, so we'll go through the whole problem. There's a second part to this. So the volume of the water, the height of the water is, so the cylinder is half full of water. So half of 9 is, that's 4.5 from there to there. So to get the volume of the water, 3.14 times the radius, 5 squared, times h, and h is 4.5. So you multiply them, what did you say you got? 353.25. 353.25 centimeters cubed. Alright, so that's the volume of the water, so we'll write it in here. Right. Okay, so just rub that out for a second. Now the second part of the question. So a sphere, and the radius of the sphere, the cylinder has a radius. Okay, so when this sphere is dropped into the water, dropped into the barrel or the beaker or whatever it is, the level of the water, if you look up, the level of the water goes up by 4 centimeters. So it goes up by 4. So it goes from here, which is 4.5, and it goes up 4. So it goes up to 8.5. But anyway, the height of it, the height of this section, all that matters now is the height of this section is, the height of the cylinder here is 4. H is equal to 4. So we can actually forget about the rest of the cylinder for the moment. So we're just looking at this cylinder here. And we know the radius of that cylinder, don't we? So that's the height of the water that went up. Keep looking up here. We know that the radius here is 5. So we're just looking at this part of the cylinder now. Because that part of the cylinder is equal to the volume of the ball that I dropped in. Alright? So we have a cylinder. So this cylinder here, this is the height of the water that it went up. So that's 4, the height is 4 and the radius is equal to 5. So we can get the volume of that water. And the volume of that water is equal to the volume of the sphere that I dropped in. So we have to find the radius of the sphere that we dropped in. So first of all, we'll get the volume, the two volume formula. What's the volume? The formula for the volume of a cylinder? Pi r squared h is equal to the volume formula 4/3. Aren't those two volumes the same? It is, because when I dropped the ball in, this is how high the water went. This is the cylinder that we're talking about here. Same one. The volume of the water that went up. Right, so what we can do is, what's on both sides that I can take off? If it's a balancing act, I can take off pi from that side, pi from that side. Both sides should still be balanced, right? We have the radius on this side, 5 squared, and we have the height, 4. We have 4/3, and we're looking for the radius on this side. So what's 5 squared is 25 times 4, 100 is equal to 4/3 r cubed. What do you do? What do we say all along? What do you do if you want to get rid of 4/3 in front of the r? Divide both sides by? Yeah, if that was 2r cubed, you'd divide both sides by 2, wouldn't you, to get rid of the 2. So we're dividing both sides by 4/3. Four over 4/3 is 1, so that's 1r cubed. So now we've got 100 divided by 4/3. Okay, divided by, I'll just do it for this, 75, right. 75 is equal to r cubed. So now we get the cube root of 75. Third root of 75. And here on the calculator, it's up here. Third root of, so the second function, hit that button, 75 is equal to 4.217. So r is equal to 4.217. R is equal to 4.2.